alerts are present, how basically it works. And we'll also study some of the use cases that are there that you have to develop. First, we'll see what is use case, and then based on that, we'll also see like what are the types of use cases and how exactly are they, what logic and everything is applied. So today also we'll go through the theoretical part. In the next lecture, we'll probably have practicals, and we'll see how a same, integration or anything is done and how it looks like and how the alerts are seen on the tool. Okay. Uh, let's take a look. Sharing my screen. I hope it's visible, right?
Yes, sir.
Okay. So basically, we'll see couple of same tools, at least for theoretical part. However, all the components or all the same tools have the same working. They have the same architecture. Their components are almost same. Just some of the functionalities is a bit here and there, but most of them they remain the same. Okay. Now, let me show you. So basically, there are three components. Okay, in ArcSight. One is your uh, connector, second is your logger, and third is your ESM. Okay, so let me put this is as connector. This is your logger. This is your ESM. Okay. Now, so this is responsible for log collection, normalization, and parsing. Okay. This is your indexer kind of, which you will search your, where you will do your log search. And this is your front end monitoring. Enterprise security model. That is the full form of this ESM. So basically, whatever the logs that are, that you want to integrate, maybe a firewall, Windows device, Linux device, everything, they are sent to this connector. Okay. From uh, connector, they are sent to logger, where logger will, store the logs and everything. And from there, it is sent to SIEM. Okay. Uh, so logger is basically something that you will do the log searching for. So let's say if I want to, search particular logs for last 7 days or, last 1 month or something like that. So that you can do it on logger. So basically it is a GUI where, you can just put in your search, mention the time frame and you can search the logs. ESM is where all your what you can say monitoring happens, or you can see all the alerts, and based on that you can do the analysis. Now basically, like, we have this SOAR, as I explained last lecture. So SOAR basically helps to create the ticket automatically. However, if SOAR is not there, this is the place where you can monitor, and then you can maybe generate a ticket and everything. So basically, when I was working as L2, that time SOAR was not there. So we used to do all the monitoring over there on the ESM part, and whatever the logs are there that, sorry, the alerts are there that we used to monitor and then raise the ticket for those critical alerts. So that is what we used to do. So yeah, this is how this works. So from connector it is sent to logger, and to logger it is sent to ESM. This is basically called as linear architecture. Okay. Why linear? Because it is just in one single dimension from connector logger to ESM. And thing is over here, what happens is, let's say one of your connection gets down. Okay. Now, suppose the logger gets down for some reason. The logger server has some issue. It restarts or something. The whole connection will break. You will monitoring will get affected in that case. So now, this is fine if you have very small organization. But in cases of big organization, there is some other architecture that is, uh, deployed that I'll show you. This is called as HA, that is high availability architecture. Okay. Now what happens is over here. So by the diagram, you must have understood what exactly this means. Is basically it will have so connector server is there. In connector server, there will be multiple connectors. So what do you mean by multiple connectors? So basically, connector. So for connector, you know, for each connector, for each integration, let's say if you want to integrate Windows server, there will be a Windows connector. If you want to integrate Linux connector, there will be a Linux connector. For Oracle database, it will be a different connector. So it's not like there will be only one connector. So suppose this is Windows device, this is Linux, this is your router, this is your uh, firewall or database. So as I told you, right, that the Windows has pull method. So in that case, there will be a connector which uh, does the pulling from the device, Windows device. Then Linux will have its own connector. Maybe this router switches will have their different connectors. A database will have some different connector, new one. So each type of device, will have their own connector. It's not that one connector will collect all the logs. Okay, and then over here, those connectors will do. the parsing and normalization of those connect of the logs and everything, and then from here it will be sent to logger. On logger, as I told you, the searching is done, and all the what we can say storage of logs is done over here. Either here they are done, or if there are some old logs that that are there, then it is then stored onto maybe a storage tape or something. Okay. Let's say that you have a retention policy of 1 year or 2 year. So what happens is basically it will uh, what you can say it will probably store 3 months of data online, that is on the logger itself, and rest of the 9 months it will store on the another device, that is your archival. It will store that archival data onto a uh, storage tape or something like that. This is how it will store the logs, and if needed it has to then first fetch the logs and then search it. Here, as I told you, all the monitoring and everything is done. So the L1 analyst will do all the monitoring on this part. This is known as dual, uh, not dual, this is uh, high availability. Now let's say before timing it as high availability. What do you mean by HR high availability is basically if one of the connection goes down, the second one won't be hampered. So in that case, if you want to deploy it as high availability, this is dual destination rather way. This is called as dual destination. Okay. Why? Because connectors are having two destinations. One is logger, one is monitoring. And basically, each component will have this, what we can say, log forwarding facility from one component to another, except for ESM. ESM doesn't have. Connectors will have, loggers will have. So it is possible to have this linear architecture that we saw. But other than that, ESM won't have. So usually the linear will just have connector, logger, and monitoring. Sorry, ESM. In dual destination, what we are doing is we are sending logs at logger, and we are also sending the logs at what you can say at ESM as well. So in that case, even if my logger goes down and or this connection basically breaks or something like that, then also uh, the ESM will continue to monitor. It won't have any impact. Or if this goes down, then this will work. There is no impact as such. There is no dependency. This is called as dual destination. Now, there is another thing that is called as high availability, and that works for now that is something that basically most of the companies go for, because everyone wants it to be available 24/7. They don't want any uh, downtime or anything. So basically what happens is, let's say I am sending right now to logger and monitoring. Now what happens is basically if this goes down, I have deployed another ESM. Okay. Over here, I have deployed another ESM, and over here, the logs will be sent. So this is ESM 1 and ESM 2. So it is deployed in such a way that by chance, in any case, uh, this goes down, then logs will go through here. And this work in a active passive way. Usually now this whatever that I said, high availability, this functionality or this architecture is there for almost all the other devices as well. So be it your firewall, be it your load balancer, be it your any other devices. This high availability is there for all the devices. Okay. This is something that is deployed so that there won't be any downtime you're monitoring or any of the functionalities basically will not stop. That is why this is deployed. So yeah, this is called as high availability, and this is how you do it. You can have multiple loggers as well. Loggers is basically also there because you eventually have the logs. Even if the logger goes down, you can still do the monitoring and everything. But what you can say, like usually now, even loggers for loggers as well, there is dual, sorry, have ability. So basically, again, they'll have this another logger deployed and multiple loggers deployed, and then the log storage will be, done. So yeah, that is how the high availability architecture works. Okay, I'll explain you in detail what the connectors is there. I already explained you like uh there are connectors like that will do the log collection and everything, parsing, and then the logs will be forwarded to logger and ESM. The let's say if it is linear architecture or dual destination architecture, or some of the way the issue any issue happens, then what happens is basically uh, the connectors have the capability of storing the logs in cache. So they do have some log storage, what you can say, kind of facility which will store the logs in cache in case the logger and ESM goes down. So if the whole connectivity gets down, it will continue to accept logs till a certain period of time, and after that, when the cache gets full, it will stop receiving it. But till then, it will stop as keep receiving it, and then after some time, it will send the logs to the whenever the connection starts, it will start sending the logs. Okay. Now there are basically two types of connectors in ArcSight. One is flex connector and one is uh, smart connector. Okay. So smart connector is something which is like uh, we can say for this the inbuilt support of that particular device is already present, or the parser and everything is present. That is what we can say in short is supported by ArcSight. So this so devices like Windows device, Linux device, any Palo Alto firewall, FortiGate firewall, Sophos firewall that we saw, Cisco routers and everything. So for this, there will be default parser that is present by the ArcSight. The ArcSight has already built a smart connector for that. They'll just whenever you want, you can just use those parsers. Okay. They are basically there to parse your logs. As I told you, right, the parsing of log is important. So, and each device has its different parser, and each parser is nothing but your connector. That parser is built in your connector. Then there are some devices. Let's say, for example, if there is any any kind of a tool like uh, maybe an XDR. by Trend Micro or EDR that is not yet built a parser for. Then for that, there is something that is known as Flex connector, which is connectors not supported by ArcSight. Okay, now basically these are the connectors which have not been built. I mean, these connectors are not built yet by the ArcSight as a default one. So that time you have to either raise a FR, that is known as feature request. This is basically if any device is not supported by ArcSight, you can raise a request to do so. Okay. However, this is something that this may take some time, and let's say if there is a requirement by your customer that they have deployed their for example a WAF device, that is web application firewall device, that they have deployed onto their premises, and they want it to be monitored into the same tool, and you you have this ArcSight tool and you say that, this is not supported by the ArcSight. There is no default connector. So, it is not possible to right now to connect it. So, and you then raise a effort to the ArcSight, and customer is, not ready to wait for so much of time. So basically what happens in that case is basically you nowadays, like most of the companies have their own team, uh, that that is, what we can say, that has the capability, or they are ready to do the uh, parser building part. So this is basically where regex is used. Regular expressions is a language that is used to build this tool, and uh, uh, they'll make sure that their connector is built, and they can then parse the logs to so that the integration gets done. So that is what you know what we can say a flex connector is used as, and what we can say, previously, there used to be a dependency on the OEM, that is the ArcSight vendor, so that they provide this flex connector. But nowadays it is a kind of requirement, or demand, where if you are able to build the regex, then it basically helps to progress on this part. So yeah, this is how it is. Like there are two connectors. One is supported by the ArcSight, one is not supported by ArcSight. Then you have to build that tool, and uh, there is also, like, sometimes cost and everything is involved. That is a different part. Uh, like whatever there is in the scope, if it is not in the scope, then you have to pay. The customer has to pay for that particular parcel. So in short, this is what we can say, a default connector, and this is your custom connector. Okay, this is built whenever the requirement is there. Fine. So we already saw the pull and push mechanism. Okay. Next is, I guess. Okay. Yeah. And to make things too easy to understand. So whatever that we connectors we saw that, right? Sorry, or the components that we saw, your connector, logger, and ESM. So basically, uh, a server is built for them. That can be your Windows server, or or your Linux server, and just that a separate server is deployed, and then those tools are built on that server. And it can also be on premises, it can be on virtual machine, or it can be cloud, anything. All these three facilities are now there. On premises hardware is something which is cost bearing, so you will have to pay, quite good amount of money for that. And but basically it provides the reliability and performance. Otherwise, if you want, you can have it on your virtual machines, or you can even have it on your cloud. Okay. One thing I forgot to tell you, the port number. So there are particular ports on which the uh, what you can say, the connectivity builds upon. This is your connector. This is your logger. This is your ESN connector. Logger ESN. Okay. So from connector to logger, it works on port 443, and here it will work on 8443. Okay, this is that there by default port. Usually this cannot be customized. You'll have to build a connectivity between all this, and all the data needs to be sent from the uh, port mentioned port itself. Even if there is a linear architecture where we saw it from connector to logger, and from logger to ESM at that time as well, the connectivity is sent from here. Then also you have to send it over the port of 8443. Okay. Now there are some features, okay, that are present for the connectors uh, that are okay. First is aggregation. So basically, now let's say if you consider a firewall, or your Windows device, so it may have your lot of logs are there in any active environment or something like that. Then, and if you don't apply aggregation, what will happen is basically it can saturate or bring down the network or something like that. The traffic will increase and it will cause an issue. So aggregation is applied. In this aggregation, uh, or basically you want a particular type of logs, just to easy to understand. If you want a particular type of logs, and based on that logs you want your alarms to get triggered, because if you don't have any threshold or anything, the alarm will get triggered in high number. So for that you have this aggregation called as now let's say if you want a brute force attempt. So but let's put it for the use case. Now, basically, what I mean is, if if you want alarm to be getting triggered for 15 logs in 30 seconds, then this alarm will get triggered. That is called is your aggregation. This is what kind of setting that is present. So this basically helps to have their uh, what we can say, alarm getting triggered, or the number of alerts getting triggered are more on the lesser part. Okay. Next is your batching. Batching is the concept that are previously told, that it creates a batch. Okay. Uh, Creates a batch of uh, events or logs, and then sends it to logger and ESM. So let's say if I have decided a batch of 500 events. So the connector will wait to receive these 500 alerts, and then after receiving that 500 alerts, then it will send it to the logger and ESM. This work for all the SIM tools, right? So it's not like that, this is only specific for ArcSight. So even if, let's say if you are giving some interview for any of the other tools that let's say uh, uh, maybe you have worked on Oxide and yeah, or you have worked on Splunk and your question this for a logarithm. This flush size or batching and everything, batching is absolutely there in all the SIM tools. All these features are there in all the SIM tools. Just now we are taking a reference just to make it easy to understand. Then there is cache that I told you, right? Temporary storage on connector. In any of the case, if the connectivity breaks down and it is not able to forward the logs, it will store the logs on its own storage. That is your cache. Then next is your uh, filtering. This is this feature will reduce the number of logs. So let's say if if I apply a filter wherein don't want any particular type of logs to be sent to the logger and ESM. So I can do the filtering of that. So let's say if I am receiving a firewall alert where any changes that are done by a particular user, then uh, uh, the customer says that this is a legit activity. We don't want this kind of logs into our system. So in that case, basically, I will add that filter. I'll say that the username equal to this should not receive alert, and those alerts will be stopped. So this is the functionality. Okay, let's check. Anything else is there? Well, we can start with the use cases. Okay, fine. I think we can go ahead with the use cases. First, I'll explain you what is the use case. The use case is basically the configuration of alerts. Okay. Now, let's say uh, I want to configure a use case for malicious communication if it is observed in my environment. Okay. Now I'll explain you how it works in my environment. Usually, it is there for everyone's environment. So I am building a rule now. I'll first explain how it is basically built. So basically, see, this is a CTI server. Okay, this CTI server will uh, collect uh, what we can say data from various different devices or various different type of threat feeds. Now that threat feeds can be or any threat hunting websites or any threat hunting logs on anything. It will collect that data you must have heard about VirusTotal also. So VirusTotal is one of the threat hunting, you can say, tool, third party tool. So basically it will collect IOCs and data. Okay, and let's say if any IP that is observed, in multiple threat hunting tools or threat hunting websites, then in this CTI server, the entry gets added of that particular IP. So let's say it is a 13.5.7.2. This is the IP that gets added into the entry of CTI threat feeds. Okay. Now in my same server, I have created an alert where this is my same server. Now I have created an alert in such a way that if source IP equal to this particular IP, whatever you know, whatever that is seen in this CTR thread feed, it gets matched. Then in that case, the alarm will get triggered. CTI server, CTI list. Then the alarm will get triggered. Okay. So in short, let's say that uh, this is the uh, company's what we can say, this is company's network, and in that this is the firewall of that organization. And in that organization, if an IP occurs that is present in the CTI feed, in this case, let's say 13.5.7.2, if that IP is observed in the firewall and in the logs, if such kind of thing is observed, that in the source IP. So I told you right yesterday, we'll have different types of field, and the firewall logs will basically have this, like source IP, destination IP, source port, destination port, protocol, time, and everything will be there. So in that case, all the logs that are sent to the SIM, and in that log, if something like this is observed, that this IP, an IP that is present in this CTI feed matches with the source IP, then your alarm will get triggered. So then on this part, your alarm of successful communication from malicious IP. This alert has gotten triggered. Okay. And yeah, the action, the what we can say, not only this part. So condition will be source IP equal to CTI list, and and action equal to allow. Why? Because if it is denied, then there is no need for you to take action. Okay. So in that case, the basically this uh, use case won't be make of any sense, since it is already blocked. It is required that you have it as kind of where it is getting allowed. So that is what you want. Okay, understood. So this is a use case. Just to make you understand, this is a use case of successful communication from malicious IP. And this is what exactly you have to do the monitoring for. Okay. Now, sometimes what happens is some of the companies now have deployed this SOAR. So what happens is basically where over here, once the alarm gets triggered, okay, this SOAR tool, what it will do is this SOAR will see that this alert has got triggered, okay, from ESM. It is building the ESM itself. So wha- what it will do is basically from here you can see that the SOAR is deployed and everything. So once that SOAR gets notified about this, it will create basically and ticket into that ITSM tool. Then it has seen this alert got triggered. It has this playbook. It will go and directly block this IP onto that firewall. And once it has checked that the IP has been blocked, it will get notified about that. And then from there, it will again from that ITSM tool, it will directly resolve the ticket as well. So usually in what in cases what happens if SOAR is not deployed, the alarm will get triggered. Now, as I told you, right, there are two types of SOAR events. So one is L1 playbook and one is L2 playbook. In L1, it will gradually generate a ticket and just place it on the ITSM tool. That is your servicing ticketing tool. In L2 playbook, this functionality happens. So if only L1 it is deployed, uh, the analyst it will do is it will basically assign it to customers bucket or it will assign it to firewall bucket, and from firewall it will go and block the IP. Then the firewall team will notify and say they have they have done the IP blocking. Then again it will assign it to the SOC bucket, and then SOC team will close that bucket. So basically eliminates all this manual work. Okay, this is how the basic use case is there. Now we will see some other use cases as well. One of the most common and by default use cases is there is the brute force login attempt. Now we have already seen in our previous lecture regarding the brute force. Brute force is something where multiple attempt of login failure happens, or multiple attempts of password what we can say, multiple passwords are entered to crack the username. So to have this as a use case, basically what happens is, now this is my uh, server. Okay, I told you yesterday, right, in Event Viewer, we can see these logs. Now here you can see the event ID, right, 4624. Similarly, for each event ID, sorry, for each event there is an ID associated with it. So this is my server, and the logs are getting sent to my SIM. So what happens is basically, now if there is some login failure that happens, so for that event ID is 4625. 4625 is a event ID for uh, login failure. Now if you just use for one login failure, it won't make any sense. Now you have to do the aggregation, that feature that I told you. Aggregation is basically somewhere like what you can say, if you observe 50 login failures in 1 minute, then the brute force use case will trigger. So from any machine, if we see that, basically a 50 login failure happens in just 1 minute, then an alarm will get triggered. Okay. Now, humanly, it is not possible to have these 50 login failures in 1 minute. So there are two basically reasons. And one is someone is actually trying to attack your system. Two, sometimes what happens is basically I am the user and I am logging on to multiple system using that particular IP or that particular user name. And through that, there are what I can say, this alarm are getting triggered. Or sorry, what we can say is basically if I'm logging from multiple system and then I save a password to uh, into the cache or something like that, the cookies, you can see that right on the browser when you enter the password, it opts for do you want to save the password? And if I say yes, it will store the password and it will basically generate the false positive. So it's not always the case that if you see brute force login item, then some attack is happening. Most of the cases, 99% of the cases, it will happen that someone is trying to like someone has saved the password and the uh, uh, login is happening at the backend. Okay, so these are the threshold. This is called as threshold, and this is called the use case or the alarms. That I was particularly referring to again and again, that we want to monitor alerts, we want to monitor alarms. Alerts and alarms are this one, that there is some threshold that is set, and based on that, whenever the threshold or if any changes happens or something like that happens, then in that case the alarm or the what we can say, the uh, alert will get triggered and it will show you in your monitoring GUI tool, and then you have to notify to the uh, end user or whatever the concerned team is there, or the customer who looks at into it. You have to assign it to those particular teams, and then you have to also provide them recommendations and remediations and recommendations, and what are the recovery steps are there to address this particular incident. Now, there is also this tool will also help you to, now let's say this is your SIM tool. This tool provides facility to provide notifications to, uh, you can basically have it directly create a ticket through SOAR, as I told you. Through SOAR, it can create a ticket in your create ticket in ITSM tool, that is just a service ticketing tool. Okay. Then it can also uh, uh, okay, yeah, you can it can probably uh, trigger an alarm or send mail notification. So it can send, let's say if this alarm gets triggered, it can send a mail notification to the end user, or to the whoever the emails are assigned to, and it can also send messages on mobile, that just to sometimes monitor that this alarm has got triggered and you have to take the action immediately. This is done on for critical alerts, that the P1 tickets or anything, where the what we can say, the uh, 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 that particular alert needs to be get notified on the mobile. Otherwise, if you do it for all the one, uh, you will see that lot of these things are getting triggered and it will create an issue. So for that reason, only P1 are there. I'll also we'll see some few use cases, and then we'll also see what is P1, P2, and P3. How the priority are basically defined. We will see some more what you can say use cases. Okay. So types of use cases are present. The first one I already explained you, user credential compromise attempt. So this is to ensure that security detection mechanism for attempt to compromise your credentials. It may be through brute force, it may be through pass the hash, it may be golden ticket. So, basically, whatever that we saw, right? Pass the hash also we saw, and brute force we saw. So all these you have to understand how this basically attack works, first thing. Then you will have to also see what kind of logs does it generate. And based on that, you can just basically see how you can create an alarm for that. Then unwarranted privilege escalation. Okay, so monitor for anomalies suggesting unauthorized privilege escalation. So let's say if your account, we have already seen this privilege escalation, right? In our previous lecture. So privilege escalation is your, if let's say if your account is not an admin user, but it is still uh, doing something that only admin is allowed to do so, or other case you can mention that if your user itself get an admin access or admin privileges, then in that case usually a use case is present, so that let's say if there is an intrusion that has happened, if attacker has gotten into your system and it is making use of some user account who has this basically where the particular user is assigned to a admin privilege group, and then he's performing admin what we can say admin functionalities or admin functions. In that case, the alert should get triggered. Account misuse, somewhat it is similar to the previous one. So this is basically where inactive accounts are uh, what we can say inactive account is misused, or it is taken advantage of. So yeah, uh, the user accounts which which usually are not used much, and they are very used in very less number, so those are the ones that that is something which the attacker will take use of. And for that it is necessary to have that basically use case to closely monitor for these unusual activities. So basically sometime what happens is a user that is the sometimes an employee will leave the organization and user ID is not deactivated. So an attacker can basically make use of that, because then the password is not changed and everything. He'll basically be a silent worker for that, and he'll do all these functionalities and everything. So this is something where the SIM will, come into picture and see that any user which is now having lot of brute force or login failure attempts, and he's think that lot of activities are getting done, and then he will alert the customer or the owner. Anomalies in previous something as I told you, right? Again, anything that is abnormality that is present in a particular privilege accounts, not only normal account but also privilege account, then it gets usually triggered. Then traffic to suspicious domain I already told you. Okay, so This is the successful communication alert that I told you. Uh, so that is then your DLP. So whatever the tools that we saw, right? DLP is basically data loss prevention. You must not have seen that. We must not have gone through that yet. So data loss prevention is one of the tool which will monitor if there is any data leakage or anything, if there is some inside or your critical data is getting lost or transferred somewhere. Then, but we have seen the IPS WAF, these tools. We have also seen antivirus. We have spoken about EDR, XDR. So these all tools are, monitored under SIEM. And if any alert, any critical alert or anything gets triggered over there, then our SIEM should also get notified. Now, let's say if any virus is found on any of the system, and the antivirus not just it just scan and it has not cleaned or anything, it has just maybe quarantine, or it may have also left that virus, as it has not quarantined or it has not cleaned that virus. In that case, the SIM should be able to notify that virus found has been on that system, and there is some alert that has been generated, and for that then action needs to be taken. So SIM will look into these logs, it will see that alert is getting generated, and check if that particular issue gets addressed. So whatever security tools that you have, all this needs to be monitored under your SIM. Then system alterations, system changes, especially unauthorized one, pose a severe threat. Any of the system that change. So even if so use cases are there, even if your time changes on your so time change command is executed in any of the Linux device. For that also, uh, what we can say, the same should generate an alert. It is usually something that is I mean, for us, thinking that time change is not a big issue, but we have to check that it has been done or not by a because sometimes this is done to basically what we can say to uh, maybe to bypass any of the threat, or bypass getting detected or something like that. It may also be have been done for that. So it is necessary for us to make sure that this is not an unauthorized activity. Then there is DDoS detection. Now, how will you say that this DDoS or something that is happening basically uh, on your environment? How will SIM get uh, notified? So there is particularly a use case where, let's say, if my inbound traffic is having a data more than this number of KBs. So let's say if you say that I'm getting multiple hits of HTTP sync flood, and in that case what will happen is basically use case is created where it will have a single IP, and it will check for the multiple HTTP sync flags. So in the packets you can always see, right? So even if you see that source is single source, okay, and it has multiple HTTP request. Then in that case, denial of service can be detected. Okay. Malware detection, I already told you. Phishing detection. So phishing detection, we have already gone through the phishing part. Okay. Now, how will you detect phishing is basically when you have to create a use case where you see any spelling mismatch in the email, if any malicious IP present in that email, or now what happens is basically tools are present like Office 365 or other Symantec email gateway. which have their own checks, they have their own tools, and basically they are just integrated with the same. So if any of this tool notifies that particularly that this uh, what we can say this email has been marked as fish or suspicious, then it will notify the SIM will receive a log, it will match against that particular event and it will generate an alert. So that is basically how these use cases are built and how we do the monitoring. However, we are talking about these alarms. Use case will include all your alarms as well as your dashboards as well as your reports. So reports are also something which are important part as a part of for customer what we can say uh, the customer requirement sometime is there that I want report of these many of this alerts, or I want alert for users having different locations login or anything like that. So whenever you say that we have developed use cases or we have these use cases, it will also include your dashboard. Now let's say coming back to brute force, now you have this threshold brute force this thing, right? What we can say a threshold you have mentioned for any alarms and anything, and you have generated an alert for that. But you can also include dashboard for that and see if any user that is logging into multiple times. Then you will also have a report. At the end of the day, you will have this report. All this is basically coming into the under the use case part. Okay. So now. Uh, Mostly we'll have to then one by one go through the practicals itself. I'll just explain you what are priority. Then from next lecture we will start on the practical part. Now there are three different basically priorities. Okay, P1, P2, and P3. All these are based on the risk-based score. Okay, what do you mean by that? Risk-based score. So all of them are having some risk-based score. Okay, so P1 will have maybe 80, P2 may have 60, and P3 will have maybe 40. So now whenever you have integrated any device, basically, you have to assign the criticality of the device. Now let's say if you have 10 Windows Server, 5 Linux, and 5 firewalls, etc. From that you decide that, or the customer says that that from that 10 Windows server, two of them are very critical for me because they have the most critical applications hosted on it. Linux is fine, and I want all the firewalls also to have the high criticality. So now from that what you will do is basically you will have those two Windows device and 5 firewall as your critical devices. Okay, now that that this is set, okay. Other devices will have other devices, you will consider them as medium risk or medium critical device, medium device, let's say medium threat device. Now, because of this, what happens is if any of the alarm gets triggered, okay, again we'll take a example of brute force. Now Whenever brute force happens on the other devices, the rescore will be calculated based on the device criticality of criticality plus the score of alert. Okay, based on this, the brute force alert is, uh, scored. So basically, it may range between 50 to 60. I'm just, providing this as understanding for providing this for understanding the concept. Now, same thing again for critical device. Now, the device again, this criticality will, calculate the critical device for plus 4 of the alert, which may be 80 plus. And then this creates a P1 ticket. So basically, this risk-based score is calculated based on your device score as well as your uh, rule score. Then second thing what happens is basically it also depends on your number of alert that is occurring. Now let's say consider another situation. We'll take the example of same brute force. Okay. Now in this, for example, consider a user XY ABC has occurred in brute force use case at 11:40 am, 11:30 am. Okay, and for this user, alarm has got triggered on a particular system. So consider this ABC login failure or brute force alert on system 10.5.1.6. Now again this occurred, the same alert got repeated at 3:50 p.m. And now, and this is your this system is your considering as low criticality, low critical. So we are considering this to be a P3 alert. Fine. Now, what may happen is basically you have seen this as P3. You have seen is that initially P3. Again, let's consider as P3. It has occurred for the second time. Now it got repeated for same user and the same system at 11 p.m. at night. Then what happens is its risk score increases because we have seen this same alert multiple times, and now this is coming into your P2. So basically your risk score increases. This is how your risk score is calculated, and based on that your priority is defined, and based on the priority a different working mechanism is there. So for P3 you may consider a bit as linear approach. You may have some more SLA. I'll also explain what is SLA. Then your way of approaching those particular tickets is different. Whenever the priority increases, you have your response time should minimize. So whatever you have this response time for P3, P2 and P1 are different. Basically P1 of course you have to address it on immediate basis. There is also something that is called as SLA, that is your service level agreement. So what do you mean by that is your response time for tickets based on priority. So your response time for P3 might be 1 hour, P2 would be 30 minutes, and P1 it would be 15 minutes. So as per your priority, your response time should be minimum, because this defines your criticality of the incident. Whenever there is P1, consider that big issue has happened and you need to address it on priority. That doesn't mean that the some alerts like some brute force or something like that, privilege escalation, they should be considered as P1. A P1 where vulnerability may be breached. You have been seen lot of attacks. There is some high number of same type of alert. So let's say this is, I have just given you a small example. Now this is seen on multiple times in very short duration. It increases its priority and it goes to P1. So such kind of incidents can occur. This should be addressed on immediate basis, and your P1 especially is where all your organization will get into your focus, and that should be addressed on immediate basis. It can also occur with if any of the device goes down or any of the services gets hampered. So you must have maybe heard sometimes that this P1 incident, that P1 incident. So this is what this defines it as criticality. So each alert will have its priority, P1, P2, P3, and based on that, you have to address those alerts. Okay, I think uh, we can stop here maybe for today. Uh, we'll go through the practicals from next section. Most of the things, theoretical part, whatever it is, we have covered. If there are any questions from your end, you can ask them. There are no questions. If not, maybe we can conclude them. Okay, then I think we can conclude. Uh, Bye. See you next week.
Thank you, sir.
Thank you, sir.